Like, what do you think? What is here? And you could say, look, I'm 95% confident that the average is somewhere between these two. And you can do that with specific math information. Now, what if I said I was 90% confident? I am less confident. Do you think my interval would be wider? Or do you think it would shrink and go narrower if I was less confident? Somebody give it a shot. I'll give you a prize. So you're saying that, like, if I'm less confident, that I should go wider. What do you guys think? That is wrong. And here's why. Because, like, let me put it this way. If I said the average was 2.9, okay, and you said, Laura, I want you to be 100% confident that the mean is in there. I would say, I bet the average of seniors is somewhere between 0 and 4.0. I'm 100% confident I got it. Like, it's in there somewhere, I bet. Do you see what I mean? But, like, what if I was super not confident? I would say, okay, let's see, 2.8 to 3.0. See how that's, like, such a specific range? What are the chances that the actual mean is in there? Not very good. So I would say, oh, I'm like 60% confident right now that the real average is in there. So this could be like 60% confident. This could be like, I don't know, 90% confident. This could be like 98% confident. You see, like, the bigger I get, the more certain I am that the average is actually in there. I see what you mean when you were thinking, like, if you're uncertain, then you would have a wider range, right? Because you don't know the answer. But really the thing is that we're hoping that the mean is somewhere in here. And how confident are you that it has to be in there? So if I said it's between 0 and 4.0, do you see how I'm guaranteed to get it right? I'm 100% confident. But if I narrow my window, now I'm not so sure. Okay, we're going to keep going in this, and we're going to keep talking about it a lot. And eventually you will get it. This is the very first day. So we'll take it slow. This whole chapter is about confidence intervals. It's like a big part about statistics because people ask for this information all the time. So the margin of error formula is E equals Z sub C. That's your critical value. Maybe we'll write that right here. This is a critical value. Times the standard error, which is sigma divided by the square root of n. Remember the standard error from the last chapter from the central limit theorem is sigma divided by the square root of n. That's the standard deviation of the means. So, here we go. All right, now that's going to help us find our error. So what we're going to do is we are going to take a guess on this one. So what do you think? How long does the average grocery store employee work per week? 26. It is, where are you? 29.6, pretty close. 29.6. Although, I don't know if that would be true in Winona. I feel like a lot of students work in Winona. I would imagine their hours would be less. Okay, and the population standard deviation is 7.9, so I'm going to write here that mu is, no, not mu. X bar, because it's a sample. So X bar is 29.6, and our known population standard deviation is 7.9. All right, now we're going to find the margin of error using a 95% confidence level. When you use your critical value, it does need to be positive. So again, for a 95% confidence level, we just found out that it is 1.96 times 7.9 divided by, the square root of n. And they asked in this sample 40. I should have written that. N is 40 for this one. All right, so grab a calculator if you don't have one already. How do you put this in your calculator? Are there any parentheses you need? Where?
So they're divided.
Yeah, they're divided by the square root of 40. Yeah. There definitely needs to be parentheses around the 40 under the square root, or you have newer calculators, so doesn't it just automatically put a square root and then you just have 40 underneath it? You do not have to put this all in parentheses right here, because it will automatically do that for you. So in my calculator, I wrote 1.96 times 7.9 divided by the square root of 40. And I got 2.45. Do you guys get the same thing? Okay. So here, the error is about 2.45, no, 2.44, let's leave it at 2.4. And I'm going to explain exactly how we're going to use that error in just a second so that you're not confused. All right, jumping to page 2. We're going to do one of these again. Do you like these where we have like the notes on one side and the example on the bottom? It's been working well for me, so I've been keeping it. Okay. So the directions are going to go on the left. The remember stuff is going to go on the right, and then we'll have an example on the bottom that is labeled. Okay, so the first thing we need to do is we need to verify we can do this. So we're going to verify that sigma is known. And you can either have a normal distribution or n is greater than or equal to 30. Because with the central limit theorem, it tells us that if n is big enough that we're doing fine. So sigma has to be known, and it has to be normal, or n is bigger than or equal to 30. This information is in the problem. You don't have to like be a detective to figure it out. You should just be able to look at the problem. If it says normal, it's normal. Everybody remembers what normal means, right, in stats? What does it mean? A bell curve, yeah. It means like a bell curve. So you need to write that down on top of your paper, then write it down. Normal means a bell curve. All right, next you need to find n and x bar. You might need to find an average to find x bar. So again, I'm going to start writing these formulas like in the notation you're going to start seeing on the AP exam. So look how scary this looks. Remind me what this means. The summation of x. So if we add up all the points and divide by how many points we have, we get the mean. It's just how to find an average, right? And what is n? Right, so this is your sample size. Why is this thing looking so blurry today? Okay. All right. Step 3 is to find the critical values. For this one, draw a picture and use A16, A17 with your z-scores. For step 4, we're going to find the margin of error. And the formula that we just talked about was error is z sub c times sigma divided by the square root of n. Most people put that z sub c right in the middle in front of this, but I'm putting it on top to remind you that this is like a fraction times a fraction, okay? Let's stop here on our directions and start doing the example, and then we'll finish the directions as we go. All right, So step one says we have to verify that sigma is known and its normal or n is greater than or equal to 30. All right, so step one. Here right now, I see the word normal, so we're good there. I also